Unit 1, The Human Age by Elizabeth Kolbert. Human beings have altered the planet so much in just the past century or two that we now have a new name for a new epoch, the Anthropocene. The word Anthropocene was coined by Dutch chemist Paul Crutzen in 2002. Crutzen, who shared a Nobel Prize for discovering the effects of ozone-depleting compounds, was sitting at a scientific conference one day. The conference chairman kept referring to the Holocene, the epoch that began 11,500 years ago, at the end of the last ice age, and that, officially at least, continues to this day. "Let's stop it," Crutzen recalls blurting out. "We are no longer in the Holocene. We are in the Anthropocene." It was quiet in the room for a while. When the group took a coffee break, the Anthropocene was the main topic of conversation. Way back in the 1870s, an Italian geologist named Antonio Stoppani proposed that people had introduced a new era, which he labeled the Anthropozoic. Stoppani's proposal was ignored. Other scientists found it unscientific. The Anthropocene, by contrast, struck a chord. The human impact on the world has become a lot more obvious since Stoppani's day, in part because the size of the population has roughly quadrupled to nearly 7 billion. When Crutzen wrote up the Anthropocene idea in the journal Nature, the concept was immediately picked up by researchers working in a wide range of disciplines. Soon it began to appear regularly in the scientific press. At first, most of the scientists using the new geologic term were not geologists. Jan Załęcewicz, a British geologist, found the discussions intriguing. "I noticed that Crutzen's term was appearing in the serious literature without quotation marks and without a sense of irony," he says. In 2007, Załęcewicz was serving as chairman of the Geological Society of London's Stratigraphy Commission. At a meeting, he decided to ask his fellow stratigraphers what they thought of the Anthropocene. 21 of 22 thought the concept had merit. The group agreed to look at it as a formal problem in geology. Would the Anthropocene satisfy the criteria used for naming a new epoch? The rock record of the present doesn't exist yet, of course, so the question was, when it does, will human impacts show up as stratigraphically significant? The answer, Załęcewicz's group decided, is yes, though not necessarily for the reasons you would expect. Probably the most obvious way humans are altering the planet is by building cities, which are essentially vast stretches of man-made materials, steel, glass, concrete, and brick. But it turns out most cities are not good candidates for long-term preservation. They're built on land, and on land, the forces of erosion tend to win out over those of sedimentation. From a geologic perspective, the most plainly visible human effects on the landscape today may in some ways be the most transient, Załęcewicz observes. Humans have also transformed the world through farming. Something like 38% of the planet's ice-free land is now devoted to agriculture. Here again, some of the effects that seem most significant today, runoff from the use of fertilizers on fields, for example, will leave behind only subtle traces at best. Future geologists are most likely to grasp the scale of 21st century industrial agriculture from the pollen record, from the monochrome stretches of corn, wheat, and soy pollen that will have replaced the varied record left behind by rainforests or prairies. The leveling of the world's forests will send at least 2 coded signals to future stratigraphers, though deciphering the first may be tricky. Massive soil erosion is causing increasing sedimentation in some parts of the world, but at the same time, the dams we've built on most of the world's major rivers are holding back sediment that would otherwise be washed to sea. The second signal of deforestation should come through clearer. Loss of forest habitat is a major cause of extinctions, which are now happening at a rate hundreds or even thousands of times higher than during most of the past half-billion years. If current trends continue, the rate may soon be tens of thousands of times higher. Probably the most significant change from a geologic perspective is one that's invisible to us: the change in the composition of the atmosphere. Carbon dioxide emissions are colorless, odorless, and, in an immediate sense, harmless. But their warming effects could easily push global temperatures to levels that have not been seen for millions of years. Some plants and animals are already shifting their ranges toward the poles, and those shifts will leave traces in the fossil record. Some species will not survive the warming at all. Meanwhile, rising temperatures could eventually raise sea levels 20 feet or more. Long after our cars, cities, and factories have turned to dust, the consequences of burning billions of tons worth of coal and oil are likely to be clearly discernible. As carbon dioxide warms the planet, it also seeps into the oceans and acidifies them. Sometime this century, they may become acidified to the point that corals can no longer construct reefs, which would register in the geologic record as a reef gap. Reef gaps have marked each of the past 5 major mass extinctions. The most recent one, which is believed to have been caused by the impact of an asteroid, took place 65 million years ago, at the end of the Cretaceous period. It eliminated not just the dinosaurs, but also the plesiosaurs, pterosaurs, and ammonites. Since then, there has been nothing to match the scale of the changes that we are now seeing in our oceans. To future geologists, Zawasevich says, our impact may look as sudden and profound as that of an asteroid. If we have indeed entered a new epoch, then when exactly did it begin? When did human impacts rise to the level of geologic significance? William Rudiman, a paleoclimatologist at the University of Virginia, has proposed that the invention of agriculture some 8,000 years ago and the deforestation that resulted led to an increase in atmospheric CO2 just large enough to stave off what otherwise would have been the start of a new ice age. In his view, humans have been the dominant force on the planet practically since the start of the Holocene. Crutzen has suggested that the Anthropocene began in the late 18th century, when ice cores show. Carbon dioxide levels began what has since proved to be an uninterrupted rise. Other scientists put the beginning of the new epoch in the middle of the 20th century, when the rates of both population growth and consumption accelerated rapidly. Zawasevich now heads a working group of the International Commission on Stratigraphy, ICS, that is tasked with officially determining whether the Anthropocene deserves to be incorporated into the geologic timescale. A final decision will require votes by both the ICS and its parent organization, the International Union of Geological Sciences. The process is likely to take years. As it drags on, the decision may well become easier. Some scientists argue that we've not yet reached the start of the Anthropocene, not because we haven't had a dramatic impact on the planet, but because the next several decades are likely to prove even more stratigraphically significant than the past few centuries. Do we decide the Anthropocene's here, or do we wait 20 years and things will be even worse? Says Mark Williams, a geologist and colleague of Zawasevich's at the University of Leicester in England. Crutzen, who started the debate, thinks its real value won't lie in revisions to geology textbooks. His purpose is broader. He wants to focus our attention on the consequences of our collective action and on how we might still avert the worst. What I hope, he says, is that the term Anthropocene will be a warning to the world.